Now, I mentioned this before, but when the index is different, the function will behave a little bit differently, and we'll be looking for, like, instead this cube root or the fourth root or the fifth root of a number instead. But one thing is that when the index is actually odd, one of the things that I mentioned in the last videos was that with negatives were not allowed. That trait does not apply anymore, because when we have an odd index, say for example a cube root, negatives are actually work just fine. So let's just say, for example, with a of x, we want to know, well, what is a of 0? This would be the cube root of 0. And the only difference here would be, well, we'd be wanting to figure out what cubed makes the number on the inside instead of what squared. And with 0, it doesn't matter what index is. The nth root of 0 is always 0, because 0 to any power remains 0. And the same is true for 1. If I wanted to know, well, what is the cube root of 1? And technically, and this is called the primary root, there's technically 3 roots of 1, 3 cube roots of 1, but the most obvious one is 1, because 1 to the third power is still 1. But the thing about this is a little bit different, is if we plug in negatives, negatives actually work just fine, because if I wanted to know and think about, well, what number cubed makes -1, the answer is actually just -1. It's very simple, and nothing changes, because if you think about -1 cubed, that would be -1 times -1 times -1. Well, when you have 3 negatives, the outcome is actually negative, which is why you can have a cube root of a negative and it will remain negative. So unlike with a square root, where you can't take a square root and get a negative, you can't take the square root of a negative because it will be something that is not real. You can take the cube root of a negative, no issues, because a negative number cubed is still negative, and it's totally fine. And otherwise, the only other difference is, say I was trying to find, the cube root of 4, where there's a square root, the square root of 4 is 2, it's not going to work nicely. But say, basically, if we wanted to evaluate this simply, we'd pick numbers that had a simple cube root. Like, for example, 8 is the cube of 2. 27 is another number which has a very simple cube root, because 2 cubed is 8, and 3 cubed is 27. And remember, with cubing, you want to make sure that you're multiplying 3 times 3 times 3. Make sure that that number is a repeated factor thrice in order to maintain that it has a cube root. And say you weren't really sure, like say for example you wanted to know, well, what about the number 50? Is this a cube root of something? Of course, you can always do this in your calculator, and the cube root option is in your math menu. If you go into math, and you go down to number 4, notice the cube root is right there. And if I want to take the cube root of 50, I could check, well, is this rational or not? And quite clearly, when I'm using a calculator, I can figure out, okay, this number, there is no whole number cubed that makes 50. So, as I said before, sometimes it results in strange answers, or we get irrational values, which are, that should be 3.68, which are non-terminating decimals with no discernible pattern, irrational, just like we would with square roots. And say, for example, we wanted to move on to fourth roots or fifth roots of higher and higher indices. Well, whenever the index is even, that is when negatives are not going to work. So say, for example, I wanted to know what's the fourth root of -1. Well, again, I would be asking myself what multiplied together 4 times makes -1, and it's not going to happen. It's not going to be part of the domain, because it's going to produce a no real number. 1 multiplied out 4 times can make a negative. And so -1 will not be within the domain. But, say I wanted to do b of 1, again, the fourth root of 1 is always going to be 1. Any root of 1 is 1. But say, for example, I wanted to know, what would be another number. 16 is another example of a number which is a perfect fourth. Not like the music term, just meaning that it's literally 4 of the same number multiplied, which, the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And as you have a higher and higher index, it becomes harder and harder to figure out, okay, what are the numbers that produce easy answers, because you're literally looking for a number which multiplies together 4 times to make the inside. And of course, you can always use, if you want to do a higher index than 3, you can use number 5, which is often referred to as the nth root function. And in order to do that, you want to make sure that you you can always type in some calculators require you to type in the index first, but you want to make sure, you have a 4 up there before you're doing it. And you can always check, to see what the higher roots of a number is. And then, when looking at the fifth root, just as I said about the cube root, whenever it's an odd index, negatives will work just fine because the fifth root of -1, is -1 because -1, when multiplied out 5 times, 5 negatives remain negative. So summarizing, negatives are fine within in a radical function when the index is an odd number, but when the index is even, negatives do not work. Otherwise, they're all kind of similar. They're all the same. We're trying to figure out what number makes this number to the nth power, depending on the index. In the next video, I'll talk a little bit more about domain of when the index is not 2, because I talked a lot about the domain prior, but it's kind of applying the same things I was talking about in these last 2 videos.